Let's use Newton's method on this third-degree polynomial, and let us compute the second term in the Newton sequence, so to say. For this, I summon the theorem. Just a quick recap. F is a map into the reals, and it is infinitely many times differentiable. This is indeed true in the case of polynomials. Polynomials are part of a very nice class of functions. And if we have some initial guess, then this iterative scheme applied infinitely many times gives us our, one of the roots of this function. So we interest ourselves only in this part for the sake of the computation, but in principle, every single component of this theorem is relevant for our problem. Nevertheless, so we have the value for x1, we're looking for the value of x2. I don't think it gets simpler than that. Plug in n is equal to 1, then here's what we get. So x2 is then equal to f of x1 divided by f prime of x1. Well, x1 is equal to 1, and then you take away f of x1. So when I plug in x1 here, I get 1 cubed plus 2 times 1 minus 4. This gives me minus 1. And then what remains is to take the derivative of this, 3x squared plus 2. And then if I plug in x is equal to x1, so if I plug in x1, which is equal to 1, I will get 5. So in principle, the answer should be 6 over 5. And perhaps it is a good idea to take a moment and to check this myself. Yes, that is correct, which means that I don't have to shoot this video once again. So that's good news for me and for you as well, because in this case we end this tutorial very quickly. I know you're excited to see me, as always, but this time I have to end it so hastily. This is the answer.